That's my starting cue. Hello, everyone. So after a whole 2 years of COVID, I'm still getting used to the in-person, and gotta say, I absolutely love it. I've kind of missed meeting with so many awesome people. Just for the audience, I can't see the chat much, but I think Scott will be monitoring it. And yeah, in terms of questions, we'll save it for the last. So whatever question you had, you forget and you don't ask. Anyways, just kidding. Let's begin with the talk. Cool. Wasn't expecting Jack to give a full-on intro, so I think this slide is slightly outdated. But anyways, I'll tell you everything I not do outside of cybersecurity. So when I'm not doing cyber, I like to get a bit creative. I dabble a bit into video editing and visual stuff, as well as I'm a jack of all trades, master of none kind of thing when it comes to social sports, movie, soccer, whatever it is. Cool. And yeah, so like Jack mentioned, before Atlassian, I was a developer, software engineer for a few years, and then transitioned into security. Big thanks to my manager, Chava there. That's a shout out. Cool. That's enough about me. Let's focus on more of the talk. Cool. I quickly wanted to discuss what's today's agenda and what's today's talk about. So what I wanted to focus on first is in the modern web security world, what are the most common and dangerous things we see happen? How do we protect against them more from a defensive perspective? And finally, alongside, share a lot of resources in Q&A. And this is not necessarily the order, but instead we'll go through, it'll be broken down into different type of attacks. So for each attack, we'll just touch on it, the defensive mechanism, and finally some resources. So that's that. Cool. Some quick disclaimers that I want to make. I've assumed that the audience, both in the chat and as well as in the room, are from a very wide background. We have security engineers, developers, managers, and much, much more. So it is, it has a good, I've tried to make it a good mixture of depth versus breadth as well. So bear with me if some things are a bit more surface level, but the context is required before we dive deeper into it. For all my talks, I prefer the Chatham House of discussion, which is feel free to use this information in any way, everywhere possible, without any needing for any acknowledgement or say who did you hear it from. Cool. And yeah, if we were to talk about all the areas you can attack front end, it would be a talk of maybe a bootcamp of 1 month instead of a 1 hour long talk. So this is going to be a bit more targeting at the high risk areas. Awesome. Before we dive into the vulnerabilities, just quickly onto the landscape itself. Can the audience see these slides and read some of the things? A quick heads up is I've made some of the slides intentionally a bit more detailed. So I'll be sharing the links afterwards anyways. So don't worry if you don't get the chance to read everything and anything. But yeah, moving forward, in the last few years, especially due to COVID, we've seen this rapid digital transformation where everyone and anyone seems to have a digital presence. And it was not necessarily just by choice, it was by necessity as well, because in a rapidly distributed world. And how we create web apps has changed significantly. So I have a question for the audience, and whenever I ask a question to the audience, I'm going to look down and change the camera so the online people can see the audience and interact as well. So if you all see me looking down there, that's the explanation. Got it. Switch camera, audience. Cool. I've got a question for the audience, and raise your hands if you have created a web app just using HTML, CSS, and JavaScript, nothing else. Quite a few, right? And fast forward now, using just those three is a very, very rare occurrence, right? We have so many modern frameworks, all these new tacky ways. There seems to be one new framework every other month or week. And in the middle, we made the mistake of PHP as well. And now we are sort of moving forward. So the way we make web applications has changed drastically. And these things have caused into some new vulnerabilities that we haven't seen before. Some of them has been the biggest talking points of 2020, and we'll see some of our very old enemies still sticking around and causing us lots of hassle. So yeah, let's dive into that. Cool, first things first, code injection attacks. In the same tangent of rapid digitalization, the way the amount users interact with our web applications has increased drastically. Gone are the days web was just a thing to read. Now it's a thing to interact, engage with, and all of those things increase the attack surface as well. So the places where you can chuck in a code instead of a text and your web application needs to handle it properly has increased a lot as well. So the scenario where you're expecting a search query and it's instead of a text and it's a code, is your application resilient enough to handle it properly? That's another point. Cool. Cross-site scripting attacks. Now, how many of the audience? Oh, flip the camera. Good cue. I'll flip it right after this question. So how many of the audience already know? I'm just trying to set my pace. How many of you know already in a good manner what is XSS, how to protect against it? See quite a few hands up, almost all the hands up. Good. Not everyone. I can't see the chat, Scott, so you'll be my mouthpiece there. I'll flip it back to the presenter. So it seems like we have a fair understanding of XSS, so I wouldn't be diving too much into it, but XSS in React or Angular doesn't mean much if you don't understand what it is by default. So I'm just gonna really power run through it, which is XSS is basically code injection in your application through the browser. So the medium here is the browser, and the vulnerability or the actual weakness is the web application, because the way we have built our browsers, and that's something we can't change that much, is whatever you give it, it has the tendency to run these days. And it is up to our application to make that confinement on what to run and what not to run. And XSS can be from minor annoyance. So the good old anonymous days where they used to do defacement using XSS to these days full account takeover. Things like that is completely possible. So this is just a quick example where it is expected to have text, but what if it's a script? How it's going to handle? Cool. So a quick visual example where the attacker might craft something, a malicious link like this, where it has some dangerous URL, and then send it to the user. If they click it, because the website doesn't have any proper protections, it runs that code, and basically the attacker, in this case, let's say the target was to get the cookies of that user. That is possible. Cool. So it can have drastic impacts in real world, and we've seen some of the biggest bounties to some very eerie cases happen due to XSS as well. That was pretty much a power. Oh, one more slide. Before I move on to React and XSS, I wanted to sort of demonstrate that XSS can happen everywhere and anywhere. A lot of the times when I speak with developers, they're very focused in protecting the more sensitive pages like login pages and other things. But this is an old vulnerability in Atlassian where XSS happened in one of our products, which is Bitbucket. For people who do not know, Bitbucket it's a code management tool similar to GitLab, GitHub, and other stuff. So the XSS was in the pull request window when you click on the button, create a pull request, and that button turned out it wasn't just marked down. You can do all other things with it as well. It's an old one. It wasn't drastically catastrophic one, but yeah, just to show it can happen anywhere. Cool, XSS in React. To understand that first, let's talk about, in general, again, a question to the audience. What's the best way to prevent XSS in your web application? Now, all of these can be used in tangent, but if you were to pick one, best one, Dan? Data validation. Someone else? 3. Context sensitive. I see a lot of hands. 3. Yes. You're right, Darren. Data validation is a step, but with the wider audience, the context-sensitive output encoding is usually understood as the best defense against XSS because once you're doing context-sensitive input-out coding, you have control on where the data is going to run in the context of the application, so you know where it's going to end up. Whereas when you're relying on just data validation and sanitization, you do not know where exactly the data is going to flow and where it might end up. It might end up in places you didn't expect it to be, and as well as there's all kinds of bypasses. Content security policy is a good way to mitigate, but it's not. It's just an added layer, and the first one is just garbage. It doesn't do anything. It's not security. Cool. So good news is React does context-sensitive output encoding by default, and what that means is if when you put something, let's say a script or some kind of code, React wouldn't output it by default. It would convert everything into string and output it. So yeah, React is quite secure. And thanks for coming to my talk. That's everything. Unfortunately, that's not the case. There are multiple ways you can bypass the security of React and perform XSS attacks. One of the top 3 ways is how React allows you to interact with the DOM. There's something called React escape hatches, as well as the proper encoding of different HTML elements like URLs and other stuff. Let's look at them a bit in deep. Cool. So if you wanted the ability for the user to interact with React and interact with the website and have that ability to display stuff dynamically, there's something called the dangerously set inner HTML that React has by default that you use to allow HTML output. For example, the same code as before, if I rewrite it with dangerously set inner HTML, and I put things like the HTML tags, it's actually gonna output it as well. So it has no sanitization, no output sensitive encoding by default, which is fine, right? Because then we can rely on things, third-party libraries like DOM Purify and other things to make that HTML safe. However, the issue becomes, this is not just a random screenshot of code. This is actually the React's official website where if you Google how to inject HTML and other stuff into React, what's the suggested way, it will show you the dangerously set inner HTML and how to use it. And in nowhere, it tells you that, hey, it can lead to XSS and you should be careful and you should use the proper method, but in nowhere it tells you what is the proper method. So it is relying on the developers to first understand what is XSS, what's its extent, and then go look into what's the best way to handle that and implement that and do all of that all by themselves. And that's where the most dangerous issues happen. And if I do a quick search of dangerously set inner HTML in GitHub, I get more than 1 million hits. Now, I'm not saying all of them are a dangerous sync and can lead to XSS, but has all of those developers properly implemented and researched into the proper way? We do not know. So that's definitely one of the big issues we see still a lot, that when people get started with dynamic content generation, they don't have proper guidance. And how to defend against that? So the good news is most modern SAST and DAST and other tools are going to pick dangerously set inner HTML up. Even if you have sanitization and other stuff, it's going to give you a warning that, hey, you're using dangerously set inner HTML. This is what you, are you sure you're doing it well? So this was for one code file and one error that is doable. But in a code base like ours, where there's thousands of lines of codes and numerous instances of this, that alert can easily become from 1 to 100 to 500 to 1,000 and much more. And how do we know that which one is the valid alert and which one is not an actual dangerous sync and not a new thing the developer has created? So how do we defend against that? The most advised way is create a secure component that handles the dangerously set inner HTML and use that secure component everywhere else in your code. So this is a quick component I've just quickly typed up, which does use DOM purify to sanitize the HTML that's coming in, and that puts it into a React component, and whatever else I'm creating, that DOM manipulation and everything else, I just use that safe HTML. So what's that doing is whenever we run a SAST and DAST tool, it's going to give me a warning about this in this file, which let's say I've called it safe.html.js, right? As long as in our static scanner, we see that safe.html.js is the only warning, we're safe. And suddenly, if we start seeing it pop up in other places, we know that it's not supposed to be that the case. It's supposed to be we use the secure component everywhere. And this ties into this thing, secure by default, or the paved way concept as well. Cool. Now, one thing people might be wondering that, hey, why do we even need to handle dynamic content? Like, can we just not avoid using it anyways? So we might not think, but in the modern web ecosystem, there's so many ways the user often requires to input dynamic web content. For example, if you look at something like Confluence, where you can do all kinds of things with your text, that might be a dangerous thing where you need that dynamic content generation. And this is just one example, one extreme example where the user is able to inject all kinds of things into the page, whether it's via comments, whether how the formatting of the text and much more. And there are other examples like that throughout. Cool, let's look at some more React XSS vectors. The other one is, before moving that, I've been so bad with the camera management. It's still in presenter mode, so I didn't need to change. So what do you guys think is a React escape hatch? One, two, three, four. Any guess? I see number 4 from Josh. Cool, you're correct, Josh. Your internship is successful. We should give you an offer. Cool, so it is a way to directly interact with the native DOM API. So as we have seen, dangerously set inner HTML is a way to output HTML directly, but React, as creative as it is, it gives you other ways. In this case, find DOM node and create ref as escape hatches. And what that escape hatch means is you can use those methods to directly inject code into, or HTML elements into the web page without having to use anything else. And this is just an example where the create ref is used. And these things are so dangerous that the good news is in future React versions, React is looking to depreciate things like the find DOM node and other stuff. But we all know that not necessarily everyone, especially in a production environment, is running the bleeding edge. So we will still see cases of older versions of React where this is still possible. And the thing is, this code block, it's not something I've completely written myself. It's a little bit taken from Stack Overflow as well, where the question context was, okay, how do I generate dynamic content in React, and someone just suggested this, right? So things like this is, and as we know, at least when I was doing software engineering, 90% of my job was copying stuff from Stack Overflow and putting it and fixing bugs. So we know we rely on Stack Overflow quite a bit, and discussions like this, thankfully someone came and said, no, this is risky and use this instead. So developers might not know this is vulnerable, and they see a solution, they pick it and start integrating into the environment. This is an alternative approach suggested me by a friend, which is instead of inner HTML, you can probably use something like inner text that by default makes everything to string. I haven't used it myself and tested it myself, but just throwing it out there. And also utilize static code analyzers, or if you do pen test, things like inner HTML, outer HTML, document.in, those things are a dangerous thing to look out for as well. Cool, even more ways to hack React. Let's have a look. So I have a question. Okay, I did change the camera this time. I have a question for the audience again. Which one of these do you think can be used to run JavaScript? Is it URLs, CSS, Markdown, or all of them? Fuzzy, all of them? Cool. I can see quite a few from Scott, and that's correct. All of them can be used to run JavaScript as well. And when we are adding the features of URLs, CSS, markdowns, and whatnot, we don't often think about, okay, can the user, instead of text, put in code and that code will run? That's not in the top of our mind. But those things are dangerous. So I'm going to touch on the one that is probably the most dangerous, which is URLs. So JavaScript and resource URLs can be another potential dangerous sink. So when URLs are hard-coded by themselves, it is not a vulnerability, but when you have interaction from the user and you're not handling that interaction properly, then all kinds of bad stuff can happen. For example, apart from our regular HTTP URLs, we also have something called JavaScript URLs. And if your website is just handling HTTP URLs and not sanitizing for JavaScript URLs, this kind of things can be passed in and it can just flat out run code. Again, React knows this. The team at Facebook obviously is very, very competent, and they're moving towards blocking JavaScript URLs in future versions. Same issue with not using the bleeding versions. In the current and older versions, React gives you a warning when you use JavaScript URLs, but doesn't stop you from running it anyways. And when I see a big red blob, but my code still runs, I tend to ignore that big red blob, and I'm pretty sure I'm not alone in that. Unfortunately, that only covers JavaScript URLs, not data URLs. So if you have something like data dot whatever the code line is, that is still not going to be blocked by React, and that's something you need to handle. That's where something called CSP or content security policy comes in afterwards, and we'll have a look and how to bypass that as well. Cool. How do we defend against that? So the general guidance or the best way is avoid taking the full URL input when possible. So for example, if your website needs to embed YouTube videos and the ability to do that, instead of maybe the full URL, you can have the YouTube video ID put in from the user, and you can just pretty much attach that with the hard-coded URL and output that. If that's not possible, then obviously URL sanitization. React by default has a URL sanitization library, but it's something I'm not a big fan of because, as a lot of this in this room would know, the React library tries to do blacklisting rather than whitelisting of good URL kinds. And we know that blacklisting stuff is probably, we've learned our lessons with blacklisting and not to do that. What's the alternative? A lot of people like Angular's URL sanitization library a lot. I've seen people take that code, implement it in React, and go on with that. That's also a pretty good alternative by itself. So how do we prevent XSS in React? Very, very brief overview. Securely handle HTMLs using crafted components. So a security team might create a safe HTML handling component and give it to the developers to use it all over the code. Don't use React hatches, please. It's actually so insecure. It's considered an anti-pattern. And be mindful of other HTML elements when you're having that as well. Cool. So I've got a couple of GitHub repositories that has vulnerable React applications if you want to play around with and understand the code a bit better. The one is called React Vulna and the other was called React Suspended. If you just Google for them, it didn't make sense for me to put the link there because you can Google. Cool. Another disclaimer is I haven't covered something called trusted types. It's a new protection that's being researched by the team at Google, actually. And I haven't had the chance to look at it. It's considered the bleeding edge. Hopefully, I can incorporate it in future talks, but something for you guys to look into. All right, that was all the misery with React. How about Angular? So believe it or not, even though Angular is going towards the graveyard, Angular has better security protection by default comparatively to React. And I know that is a bold statement, and I'll quickly justify why. The first thing I would say, like similar to React, Angular does something called auto escaping. So Angular strict context escaping is pretty much the same thing as React. If you put in as a string, if you put in as code, it's just going to output a string. That's fine and dandy. But what Angular also does is context-sensitive output encoding by default. So this inner HTML, this is not to be mistaken by HTML's inner HTML. That's why I've put in it in the square brackets. It's actually a method in Angular that can be used to do context-sensitive output encoding. And what do I mean by that? So let's say I have inputted the same whoops, let me go back one slide. This same thing, input mechanism again here. And if an attacker puts like a dangerous piece of code, like an image followed by some commands to run JavaScript, what Angular will do by default is keep just the image and remove the JavaScript. So any kind of malicious code, it's going to be removed by default, and it has a whitelist of HTML elements it only allows to run. And as we can see, this is the state we want. This is something React achieves by third-party libraries, but Angular comes by default. So just to give you a quick sort of side-by-side is the first thing, input sanitization, which is also called as Angular's interpolation mechanism. If you give it just a comment like this with some malicious piece of code, it's going to have the scripts there as well, and it's just going to put everything out as string. However, if you use Angular's context-sensitive sanitization, it's going to remove the dangerous code, the scripts, but it's going to keep the safer ones and let you run those. And it's going to give you an alert that, hey, I have done something for your safety, and which is for you to follow up as well. Does that mean all rainbows and sunshines for Angular security? Unfortunately not. There are ways. So if you want to do XSS in Angular, it is possible, but it is very, very hard. You sort of need to go across all the default way Angular provides you and do something very, very dangerous to achieve that. For example, if you wanted to not use the inner HTML for some reason and use something called bypass security trust HTML, which as a developer, I see this function I would never touch, right? Bypass security trust HTML, but people still tend to be using it outside and in the wild. So that's, again, it has no input sanitization whatsoever. If you put HTML there, you might assume that, okay, it's safe, but it's completely not. Oops. Similar to React, it gives you the ability to directly manipulate the DOM using something called element ref. Nothing new here, the same thing, but just Angular version. But something a bit more dangerous I consider is the render-to API. And the render-to API is an official Angular API that lets you do the same thing, interact with the native DOM, but this thing, it has been referenced way more than the other aspects. So I consider this as a more dangerous thing. What are these doing? These pretty much allows you to take some code and run directly into your website. Now, sometimes some people might wanna do it when you know that your code is static and it's never gonna change. But if you have things that are that is dynamic, it's never a good use. From what I've heard and read, those APIs are a bit quicker when you have some static code to run. So that's why people do it. Another thing I'm not gonna cover because it's more server side and I'm doing client side is template injection attacks. It's one of the biggest things in Angular, and it's just a wild thing. Angular gets owned left, right, center with this. So even though this is a client-side security talk, I wanted to make a quick mention of template injection attack because of the drastic impact it can have. Cool. How to protect XSS in Angular applications? Again, if you're making an Angular app, stick to Angular's default ways. It's much more secure than React, and it does a much better job in doing so. Avoid a custom DOM manipulation, specifically when you have custom scripts to run. And lastly, again, a call out to template injection. All right, let's talk about this scenario. We talked about so much XSS, right? I'm kind of sick of XSS, and Bob is as well. So what if there was a way to tell the browser that, hey, browser, this is my code, and just run my code and nothing else. Everything else you see, deny by default. Well, the Genie has sort of granted. The reason I say sort of, I'll explain in a second. Bob's and my wish, and we have something called a content security policy. So what is content security policy? Again, I'm going to be fairly brief. If you want to read into it, you can look into it more. It's a way to tell the browser what code, and not just code, other resources we want the browser to run for our application and what not to run. So basically, content security policy can be done via two ways, either HTTP headers or meta tags. So this is embedded into the HTML, or as you know, when we're doing HTTP calls, this is something that can be set as a header, and then the request can be sent. So if you set something like default source is self and example.com and all subdomains of example.com, that will pretty much tell the browser to do that. Hey, the default source of all content, code, images, fonts, and a few other things, is just me. So when you see any kind of code, just run my code. And if the code is from the user or any other website, please don't run it. That's insecure. But I also am dependent on this example.com and all subdomains of example.com. So if the code is coming from them, please run that as well and nothing else. And that's pretty much what content security policy is. And it is recommended to run via headers instead of the meta tag, because a lot of the directives are not by default do not work in meta tags. They just do not by default. They just do not work in meta tags. So do it via the headers if you want to. Cool. So just to quickly demonstrate the power of CSP, if you have something like this, it will protect against 3 different kinds of React injection. So if you have your inline code, you have code from. Oh, sorry, I've mentioned inline code twice. That's a mistake. Anyways, the first one is just code injection by the user. The second one is inline code, and the third one is code from a remote source. So all those 3 typically different kinds of XSS vectors, all of those will be blocked. So from user, from inline, as well as external sources. So one thing I wanted to sort of say again, and a lot of the times it is not clear, that CSP is not a silver bullet. Nothing in cybersecurity is, right? Hey, we all searching for that. CSP is just an additional line of defense. CSP by itself is not an alternative to secure coding principles and guidelines. That still should be there. It's just an additional layer of security. Cool. Like everything else, CSP is vulnerable too. I'm not gonna, again, there's probably 20 different kinds of CSP bypass we've just seen maybe within Atlassian, but not gonna touch all of them, some of them. So the first one, first thing you might be seeing is something called unsafe inline. It's not really a bypass, it's more like a misconfiguration of CSP, because a lot of the times, and a lot of people who have worked with CSP know that when you're trying to roll out CSP, it breaks everything. So you try this directive, that directive, some things work, some things don't work. And finally, you land into this something called unsafe inline, and aha, something magically starts to work again. And just because we have defined CSP, we kind of think like, okay, maybe that's fine. We have CSP and we are making our code work. But if you have unsafe inline directive, the directive is basically a command to the CSP to do this, do that. You can pretty much get away with as simple as a script alert 1, which is the most simple kind of XSS vector, right? When we first learn OWASP top 10, this is probably the example there. So unsafe inline can't even protect against that. The second kind of one is the usage of wildcards. Again, this is what probably we see more in the industry rather than just defaults, because when we are in the industry, we need to do all kinds of things. For example, we need to load the fonts from 5 different things. Our website has assets and stuff from a lot of different places. And this code block, this CSP is actually taken again from Stack Overflow, where the developer was saying something like, I'm just checking the camera. I just remember. The developer was saying something like, hey, I'm trying to implement CSP, but my fonts are not loading. How do I do it? And someone's like, well, you can just say all kinds of, if you're loading your fonts via some URL, you can just say, hey, HTTP and data, and then just a star wildcard, which is the same as similar to regex. It will accept assets from everything else, which then is the issue, right? Because then you can put in not just fonts, everything else from other. So here, HTTPS is accepted from all sources because of this wildcard. That means if you have vulnerable code, not as a direct input, but as some other resource in some other remote server, that can be loaded as well as data URLs. So this falls back to that thing we mentioned on React and Angular, securing data URLs properly. It's a challenge, honestly. And no, one way I would say, I'll come to the solution in a sec for that as well, but a quick one I wanted to mention is something related to what we talked, is AngularJS and whitelisted domains. Again, given how we're going with the time, I'm going to briefly go through it, but the slides will be there if you want to go deeper into. But if you're using Angular and you're trying using different callback functions, this is one thing to look at. This is a bit more complicated. A lot of these kind of examples can be found this website called Hacktricks. Honestly, like I switched from software engineering to security, and my job has been looking stuff up in Stack Overflow. Now my stuff is looking stuff up in Hacktricks and find it from there. It's a pretty good website. Check it out, guys. It has, again, 20 or 25 different kinds of CSP bypasses. Pretty cool. Cool. Some of the common CSP issues we see, the first one is leaving your CSP in report only mode. So when you're rolling out your CSP, you want to be having it in report only. So instead of protecting against things, it only gives you a warning that, hey, you have this kind of potential XSS attack here, or this thing is not going to load. It doesn't affect your code at all. However, I've seen in a lot of cases, people just forget to turn it back on, and they think they have CSP, but in reality, they haven't. And I was actually talking to someone in Atlassian working for CSP in Jira, and they had to be very conscious of have a deadline on when they turn on CSP via report-only mode, and that was an active decision you guys have to make throughout. Another common issues is unsafe inline without nonces and hashes. Basically, when you have dynamic code, you either dynamic scripts, you either be using nonces or hashes. And if you don't use nonce and just unsafe inline by itself, it's gonna not protect against all these different, more potentially complicated type of attacks, although alert one is not. And it will only protect against external JavaScript. That's pretty much it. So if you have CSP and you're using unsafe inline, that's something to look at. So what's the solution for that? Using the self-directive everywhere. If you have a self-directive set by default, it protects against a lot of things. I know for the people who do not know CSP, a lot of these things might not make sense. I'm putting it out in the slide to do your own research when you feel like it, but these are some of the more critical areas to touch on. And please look into things like hashes or nonces for your scripts, because that can really help you with dynamic content. Another common thing is not specifying rules for all directives. So CSP, by default, if you don't set how fonts are going to be handled, it allows fonts from everywhere. Similarly, if you don't configure how, let's say, code will be handled from outside, it will allow code from everywhere. So that's where something like the default directive is a good one to put always, because that means a lot of the things are handled by default. Cool. Data URLs, again, it's looked down upon, something for you guys to look into. Sorry, I'm a bit going fast because I realized we probably have 15 minutes and a whole lot of things to cover. So I'll be doing things. This is again something, some awesome work Google did. They have a CSP evaluator where if you have some CSP rules. This is something where you can chuck in your CSP and it will tell you what are the things your CSP protects and what it doesn't. It's it's really handy. It's something we utilize a lot inside Atlassian a lot and externally as well. Cool. Okay, so now we're gonna pivot into a slightly different kind of attack vector. Let's say, what's a good example that can be fairly quick? Let's say Scott. Scott uses Facebook, and Scott's Facebook has his phone number. This is completely made up scenario, by the way, nothing that's. Scott has his phone number as the secondary, as the recovery method for his website, right? So if he ever loses his password, he'll get a text back with a code. And that code will basically give him the access back to his account, that this is the way to go. What if there was a way to change that phone number? And that's where pretty much cross-site request forgery comes in. And what is cross-site request forgery? Before diving into that, one quick slide on how impactful CSRF can be. So we recently, this is as early as 2020, where we saw you can pretty much do full account takeover in TikTok with a single click, which was a malicious crafted URL using CSRF. So yeah, for I think it took them a while to finish fix, and for that we didn't see a lot of dance videos because the accounts got taken over. So how does CSRF attack and what it is? So a CSRF usually requires three key areas or three requirements. The first one is a relevant action or a state change. So for example, Scott's email or phone number for Facebook, right? Usually it's done via some REST API where you'll make a call to that API that, hey, email/change with the session cookies and session tokens, and say that, hey, I want to change it to email to something else. And CSRF only happens when it's cookie-based session handling, something that's very looked down upon in the modern industry. If you're doing just cookie-based session handling, you probably are vulnerable to React. And another thing for CSRF is all these parameters, even if it's obscured, obfuscated, it doesn't matter, but they need to be predictable. So then there can't be any dynamic sort of element or header in this post request. So when those things are present, I can craft a payload like this. This is just, let's say, I'll send Scott this funny cat lovers vlog. And in that vlog page, if the website, if Facebook was vulnerable to CSRF, in that website, I'll craft something like this, where basically it's a post request with all the values set, and it will pretty much be, or it can be something like this URL where it's the change. And if Scott was logged into Facebook and it was only doing cookie-based session, so think what can happen, right? Scott is in his browser. He's logged into Facebook, and he closed the tab, but his session cookies are still there, right? You can use that to re-log in Facebook without using your password again. And if Scott clicks on that and the website, Facebook, in this case Facebook, was vulnerable to CSRF, what this URL will do is make a call to Facebook's API, asking to change his recovery email or password, or not password, or in this case phone number, to something I have crafted, which is an evil user, and make that change. And in this case, the session cookie was just saved there. It's not a new kind of attack, but even inside and outside of our company, we're seeing this is one of still the OWASP top 10. It's still right up there, and it's very, very common. So how do we protect against that? There's something explicitly called CSRF token, which are unique user-based and secret and unpredictable tokens that are used with all of your requests. A lot of frameworks like React and Angular come by default built with these kind of tokens. When I say built by default, it doesn't mean it implements by default. You need to go and still implement it. So this portion is more about for the developers to have that awareness that something like CSRF exists, and you need to go and implement that CSRF protection via the CSRF tokens. The synchronizer token pattern is the industry standard. It is by default, again, implemented in React by default, and I haven't looked into Angular, sorry about that, but I'm pretty sure that will be the case as well. For stateful software, synchronizer token pattern is there. For stateless software, the double submit cookies is the way to go. Again, I'm not going to dive deeper into it. If you don't understand it, that's fine. It's more for your knowledge. When you're making a web application, these are some of the things you might be looking into. And defense in depth is another way to go for CSRF. And I'm not just going to throw out a jargon like that. I'm going to show how defense in depth is done within Atlassian afterwards. Cool. Some of the ways we are doing CSRF protection within Atlassian is all kind of state changing requests cannot be made via GET requests. You'll be surprised that a state change like updating your email or your password does not only require post request, it can be done via the GET HTTP request as well. And CSRF tokens cannot provide any kind of protection against that. So within Atlassian, we have completely banned the state change mechanism by GET requests. We use session cookies as well, and we use the same side attribute usually set to strict. Okay, that was very jargon heavy, so I'm trying to break it down. So remember, in certain banks, you use when you in a page and you hit back the previous page, it just logs you out. It says that, hey, log in again. So that's same site cookies in action, and that the cookie needs to be generated specifically from that website. So that's an example of that. So we have things like that turned on for some sensitive pages. All state changing requests, again, must have a valid CSRF token, and that token is checked alongside something we call a course whitelist. That is basically, hey, where did this request generate? Did it generate somewhere outside of our web page, or is it within our web page? And in Atlassian, we have built an API gateway, and within that API gateway, we check our course whitelist as well as the CSRF token to see whether any kind of attacks are going on or not. So yeah, that's the example of the layered defense I was talking about. We just don't rely on CSRF tokens. We also use a course whitelisting as well. Cool. So far, we have been talking a lot about our code, but what about other people's code, right? So so when we create a web application now, the first few steps is npm install 5 different libraries and 5 different dependencies and packages, right? And something I found it always hilarious, this picture where pretty much there's somewhere some guy in a remote corner has been sort of faithlessly maintaining this repository of our npm package that seems to be powering a lot of our modern applications, and that is not a new thing. But what happens when that developer gives up on that project or just moves on? And this attack is very, very in sync with what has been happening in 2020 with the supply chain and other attacks. So what happened in this instance was a very popular NPM library. I won't name shame. A very popular NPM library basically got popped. And how it got popped is someone emailed the maintainer and say that, hey, you do not get any money for that. I'm happy to maintain on your behalf. Can you give your ownership of this package to me and I'll give you some money? And they're like, yeah, that's fine. I've been maintaining this for years and no one ever gave me anything more than a thank you. So, and someone's actually gonna pay me. Here you go, here's the code and here's the ownership. right? And what then that happened, and that was a very popular package, and with 2 million installs all over, the attacker, what they did is they created a backdoor remote code execution, and then they published this new update, and everyone's like, this package that has been not upgraded since 5 years suddenly has a new update, must be cool new features, let's all install that. And suddenly they were vulnerable to RCE. And that leads us to the third-party library vulnerabilities, right? And that is a very big issue we're seeing with within the software industry, especially the web development industry on our supply chain and others. This is the top 10 NPM libraries. I'm just going to use NPM here, and these are the vulnerabilities those libraries had. And as you can see, almost 7 of the 6, sorry, my bad. 6 of the top 10 had some kind of vulnerability in the code, and those vulnerabilities needed to be fixed. And this is again another cool example where how persistent hackers can be. This is again not my slide. I've taken it from this Pragmatic Web Security. It's a very cool blog. So basically, there was this blockchain platform, or good old crypto. Everyone likes to own crypto. Who's been following the FTX saga? Anyone? Yeah, I can see a few hands. That's good. So the attackers decided they're going to go after the crypto platform, right? And they noticed there's this Electron notifying library that they use. So what the hacker suggests to the maintainers that there's this cool new feature we can implement on your behalf. Do you want us to do it? And the maintainers was like, yeah, sure. Will you do it for free? Thank you so much. You're doing open source collaboration, Hacktoberfest. You're going to get your free t-shirt and whatnot. So they implement that, and basically that Electron Notify native update is their actual update gets published on NPM with the new feature. And that happened in March 6th of 2019. And on March 8th, the Komodo platform, they decided to, okay, this NPM package we use, it's very trusted, we're gonna upgrade. So they pretty much upgrade to the latest version, which is, again, that's fine. And after, I think, how many days? After 15 or so days, now that the trust has been established, the attacker has already contributed to that package once. They push a new change. It's a bit more complex, and it has a backdoor hidden into it. And they they create a pull request. Given this pull request, the trust is again already established. So the maintainer is like, yeah, we know this guy, we trust them, let's merge their code in. And the malicious code was in the package. And basically, and on April 16th, the Komodo platform sees another update, and they're like, okay, pretty cool, lots of activities going on. So we're gonna make this new update as well and merge the code. And that's how that backdoor was installed inside their application. It's completely by a third party. And what I wanted to highlight is how dedicated the hacker was just to get some money. They literally did and went open source contribution and waited until there's enough trust and then put in malicious payload, right? So that's the extent they can go. Now, the end of this whole saga is, I'm surprised no movie has been made about it. So NPM has a very good security team, and they detected that malicious payload. They actively look out for that. NPM security has capabilities, and I think they got alerted from their security team that, hey, this is. They noticed the security change, and then they alerted the Komodo platform that, hey, something bad has happened to you. Someone made a change that is specific to you, and they're going to drain all the money. And within this time, the hackers could have funneled the money out. They just were greedy. They were just collecting as much as, and then binding their time. So what the Komodo platform then does, they use that same vulnerability that the hackers installed. They use it to siphon the money to an offshore account and drain their funds entirely and fix the bug. So I do not know, I'm not sure if you guys completely understood that. So they used the backdoor inserted by the hacker to siphon all the money outside by themselves so they can protect the money, and then they fixed it. So they were so afraid that the hackers are gonna take the money away, and the hackers didn't get to do anything. And yeah, I'm just still surprised nothing has been, it doesn't get the amount of cool, really hacker content that went inside this. And third-party risks is something, moving on forward, third-party risk is something we are still struggling with. We see all kinds of new things like the different frameworks, different judicial regulations and whatnot. But so far in third-party dependency risks has been very poorly handled. And this is where I'm actually gonna name shame, which was the Equifax breach. I'm not sure if you guys remember, about back in 2017, it was a very big one. And it did happen for a vulnerable third-party library. And pretty much the CEO came out, the former CEO who got fired, came out and said like, oh, someone forgot to patch the library, and that's why this millions of dollars worth of data was breached, and really tried to name and shame. But this is one of the areas where we really don't know how to handle this kind of attack vectors, because it didn't happen because of us. It didn't happen, it just happened so surprisingly, because if you think about it, 5 years ago, or not even 3 years ago, if I said open trust, what comes to your mind now? Security vulnerabilities, third-party risk, all that stuff. But if 5 years ago someone said open source, what came to your mind? Collaboration, dependency, if you can rely on. So no one anticipated this kind of thing can happen. And this is one of the biggest things that is affecting the security community now. Cool. So how do we tackle open source software supply chain attacks like this? Sorry, it's been a long day. I've lost in mini golf and I'm losing my voice. Cool. So the first thing is use some kind of tools. And no, I know this sounds like the easy way out, but tools actually help out in this case. Context dependent tools like OWASP dependency check, which is free. You can use that within Atlassian. Again, no affiliation whatsoever. We have been using things like Sneak SCA and other things to detect vulnerable libraries in our code. We have been moving towards implementing frameworks like SLSA, or more called as Salsa, which the version I like. So it's a joint collaboration by the OpenSSF Foundation, which a lot of companies like Google, Microsoft, Atlassian are part of, and they're rolling out this amazing feature called Salsa. And guess what? They also have now Guac, which goes perfectly with Salsa. So check out Guac as well. So my personal hot take is, if you are relying on third-party vulnerabilities or third-party code, staying one version behind of the bleeding edge can be a good way of going about doing things, unless it's a big fix or a security fix, because you never know that this new update, is it by the actual developers or is it by a malicious actor? We really do not know these days. So staying a bit behind the bleeding edge can actually protect you when someone suddenly drops that this new update was an actual update. It was someone trying to do a backdoor into your organization. Cool. So I have no experience of writing NPM packages myself, but if you are someone who writes NPM packages and contributes, Sneak has this amazing document on NPM security best practices, and it looks at more from a developer perspective, that you're the one who's developing those NPM packages and pushing stuff out there. How do you go about doing things? This article is pretty good. Again, I'm outside of my subject matter expert there, so I'm not going to touch it, but please look at that. We're on the tail end. I'm going to very quickly talk about some of the holistic approach we have been taking in Atlassian about secure software development, and some of the highlights in the past 2 years, at least here I've been here in this company, some of the biggest wins or the things that do work. We are seeing a big push for secure by default. That Netflix talk has impacted everyone in the industry. So we're seeing things like secure base images. What else? That has been a big one. We are seeing sidecars and other things for our microservices where authentication is trying to. We are taking authentication and authorization away from developers, and we're saying you do not need to worry about that. Just plug in this sidecar, and authentication is handled for you on your behalf. It's not a new thing, but it's that is something we're going towards. And it's not just the coding aspect of it. I've been seeing a big push in the awareness side of things. We have our security champions program, our awareness training, secure coding training, and lots of other things that has making a lot of impact. Asset management is a big thing. Again, it's super hard. So I'm seeing a lot of projects that is focusing on the discovery of assets, both from a software and code side, as well as our just overall infrastructure. Things like strategic projects to eliminate a whole bug class, product-specific or company-specific is something, again, for the security engineers in the room to consider. And meaningful training and engagement. Can't get away without training, right? So that's another call out there. Cool. Hacktricks, again, wanted to make another call out to Hacktricks because how much I rely on it and how much I love it. It's a completely free website, but it has so much. Feel free to use it, contribute to it, or make donations, whatever. The donation doesn't come to me, just FYI. Cool. Thank you so much for listening to me. This is from an older talk. No, I'm not thanking Marco. I'm thanking Jack, Scott, and Sare. I'm sorry, this is an older slide. Thanks for having this or organizing this meetup, and that's amazing. Another shameless plug from me. I do run a YouTube channel that, if you like this, enjoyed this talk, I talk about similar things, and it's me and another mate. We do sort of hands-on lab kind of sessions where we take a security concept and dive deeper. We're trying to make more smaller content from videos, as well as we talk with the regular podcast style, which everyone seems to be doing so much content out there. Talk with just industry folks and have their knowledge. So 3 different things going on. Cool. Thank you so much again for patiently listening to me. I really appreciate. If there's any questions, this will be the time to ask. What's your channel called? Everything Cyber. Cool. Thank you. Yep. Maybe I get a couple. Scott has some questions, I think, or Zach.
Hello.
Yep.
What made you decide to go so in depth in this topic, given that you're not a web developer? How do you even?
Why did I? So the question was, what made me look into this topic, given that I'm not a web developer? So coding is something I do sort of for fun on the side. Like whenever I have maybe some downtime, I play around with a bit of React from time to time. And while doing it, because now that I work in cybersecurity, I have that security focus and lens. And when I was coding, I didn't really know that whether the code I was writing was secure or not. So I decided, hey, let me look at it. Let me look at how to make it a secure way. And that pretty much prompted me to look into it. This might sound like another plug, but I actually did a lot of this research in Atlassian, where we have called innovation weeks, where at least the security team, every 5 weeks, we get a whole week to ourselves to do different research and stuff. So I had that week coming in as well. So, and we need topics to do. So I was like, this is something I wanted to learn for a while. Maybe I'll do it this week. So yeah, that was pretty much how I got into it.
Josh? You mentioned CSP can be set both through headers and in the meta tag.
Yeah.
What happens when the specified CSPs conflict with one another? Like if you specify both in the header and in the meta tag and they're different.
Interesting. I think as far as I actually do not know the answer to that, whether when you set the same CSP in the header and in the meta tag, and whether it will override or not. Which one will remain? I think I've never seen someone try to do that. That's actually a fun thing. I might try it out. My understanding is the header will override the meta tag because the headers are the way to do. And another reason I'm saying headers is because a lot of directives, which are just commands, do not exist in the meta tag anyways. So if those directives you write in the meta tag and you have a different one in the header will always prevail because meta tags don't support them by default. Cool. Anything else, Scott?
Yeah, so, yeah, this might reflect my own ignorance, but my understanding is the unsafe inline part of CSP, it assumes that you don't have code that has inline JavaScript in it. And for some legacy applications, they just have it all over the place, inline JavaScript. So is there any point of trying to use CSP for these? Can you get any benefit for it? Or is it just a lost cause?
So the thing is, unsafe inline will allow you to run inline JavaScript. If you have inline JavaScript, which you can ideally look at hashes and nonces. And CSP level 3, they're trying with something new called, that's something not covered in the talk, something called strict dynamic. So strict dynamic allows you to mark the inline JavaScript that is safe. And basically within that inline JavaScript, if you are calling other JavaScript code, that trust can be propagated through that throughout that chain. So that's something new that is still being rolled out. It is not supported by all browsers, so I haven't covered it there. But strict dynamic is something to look at if that's the case. Cool, Ruby.
Nothing technical, so you know me. So often I hear from is the pressure of like getting the functionality code developed out there, and then like incorporate. This is great presentation. Incorporate all the security. Does it take time? Is that a myth? Like, I know we talk about shift left, but sometimes when the time pressure there, you need to go out. Like, is there a way that really help engineering development team to incorporate all that security?
All about security.
Yeah.
I feel like that's all. We're trying to solve that in Atlassian all the time. I don't have one, unfortunately, magic silver bullet to you give that, yes, this is how you incorporate it. Traditionally, we have seen security so we have in one side developer productivity, which is how quickly can you push code, versus one side you have security. And traditionally, the more security practices you're implementing, they slow down the deployment speed and the developer productivity, right? If they're not done well. So one of the ways push left we are seeing a lot is that concept of, again, secure by default. If you make the path the secure path, the easiest path to take, the quickest path to take, then the developers will obviously take that. So that's not one single concept. There's tons of research being done, and it really depends on what area of security you're looking into, whether it's cloud security, specific AppSec. So secure by default is a concept a lot of people can look into. But honestly, that's some of the things that challenge we're trying to solve. Like, for example, Scott, he's trying to come up with secure coding guidelines that will automatically highlight if you have unsecure code when you're trying to code, right? So things like that is a way we are. I'm not the right person to answer, I feel like, to that, because it's a problem we are trying to figure out ourselves. Cool. Any other questions? Darren, you had another one? Yeah.
What do you think of tools like SonarQube, SonarLinks, like inline?
Look, I'll say about this, about any tool, from my personal playing around with that, as well as the kind of challenges we have seen. Tools out of the box by default is obviously not going to work for everyone. So with majority of the tools, once you have first installed it, it's going to be high false positive, high alert. It's going to bog down a lot. And it's really onto the security team to make it, fine tune it, and make it as smooth as possible. It might never reach the full 100%, but if you just install a tool and go with it, obviously some tools are more high alert, some tools slightly less, but there's still gonna be a lot of high noise, high false positive, right? And there needs to be a lot of collaboration between the dev team and the security team to say, these are false positives, why is the false positive coming, can we reduce it, and things like that. I know that's not specifically, I know what you're trying to get me at with SonarQube, but I thought just my philosophy with tools in general is that by default, nothing is going to work. There needs to be some fine tuning and specialization specific to that organization. Yes, do you want me to check? SonarQube. People complaining about SonarQube, nothing new. So it's Amit, right? Yeah.
So it was a great presentation.
Thank you.
Obviously, like XSS and CSR are like some of the most exploited bugs. So my question is that, like, you had one slide, right, where you showed us that for dangerously set in a HTML, there were like 1 million matches in GitHub, right? I'm pretty much sure like Atlassian is also like a huge company, and if you do the same search, you'll at least get like 2,000 matches, right? How do you go about like fixing these bugs, and how do you prioritize like which ones to pick first? And
I suppose one of the ways we started and one of the guidance we give when it comes to handling dynamic HTML is start using the secure components, some of the secure components the security team has made. And that's, so for future vulnerabilities, it doesn't get introduced. And what I've seen is we led this strategic project called a vulnerability class destroyer. And from my readings, I wasn't part of that project, but as part of that, from what I could read from this project is what they did is they took a lot of the dangerous things, for example, dangerously set inner HTML, and they analyzed the code and tried to automate the detection. And basically, once the detection was done, certain code repositories made sense. When we look at it, if it's a lot, it has a lot of dependency, it made sense to go after it, versus if it's something like test project /123, didn't make sense. But what we tried to leverage there is on, we used SameGrep and a few other tools to sort of automatify the detection of XSS. And once that initial detection was gotten, then we started deeper, looked into it a bit deeper. Does that answer your question? Yeah. Because so in Atlassian, we have this amazing concept of security partnerships where we have security engineers who have more product-specific knowledge. So once you're doing those kind of work, we would leverage on them quite heavily, who would have that context from that application. That, for example, if a regular security engineer like me for a product I don't look after, I see the code, I have no clue. But whereas someone like someone who works in Jira, they would look at the Jira code and they would know it much better than me. So obviously leverage them and identify that a bit better. And again, we used to have this concept of embed. We're moving to partnerships, and it's the same thing. So we have, for our biggest products, we have dedicated security teams that look after it and building that product-specific knowledge for those. Thanks, Amit. Yeah, go ahead.
Yeah. On a different note, so definitely like Atlassian would have like a lot of legacy websites also, right? Which might not have like CSP.
We don't have CSP for most stuff.
Yeah, so content security policies are usually like very custom, and it is like very specific to the website. So how do you implement content security policy on legacy websites on a scale?
Yeah, so on a scale, we haven't figured it out. We are going, again, leveraging our partners. So for example, we recently rolled out CSP for Jira. Not all of Jira, maybe some Jira products. I know as soon as I said Jira Sar, I was like, no, 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 because I know how big of a challenge it is. We have partial coverage. So we, again, leveraging on the security partners and certain teams to first, oh, sorry, I think it was rolled out on Trello, and now it's going to be rolled out on Jira. My bad, my bad. So yeah, so we are going pretty much product by product and leveraging the team of that product. And honestly, you'd be surprised how much this initiative is being more driven by the developers rather than the security people. Because what we are trying to do, and again, I'm sort of being the mouthpiece of the team. Just a heads up, I have not driven that specific work. But what we are doing is we going out to the developers and talking about content security policy. This is the protection it can bring. This is what it does, and relying on them, because at the end of the day, they know the website much better or the applications much better. So we're relying on them, and it's pretty much an first priority. Like what are so the reason we did Trello, we had a statistic, something like Trello is in the top 3 applications that has XSS vulnerability. And we did that kind of analysis first, select the high risk products first, the high risk areas, and then go after them and gradually go out. Because I think as much as CSP is good, it's a utopia to have CSP in everything and anything. So ideally in real life, you'll probably have CSP in the most critical application. You hope you have CSP in the most critical applications, and the rest is secure coding and other stuff.
The security partnerships is like a very smart idea.
Yeah. Yeah.
The security teams are like, we should
Mm-hmm.
scale.
Yeah. Yeah.
Better
So,
to like outsource things.
yeah. Ooh. Oh, good. Any other questions? Someone posted a XSS sinks in the channel. So, yeah. You guys really grilling me, huh?
Just more just your thoughts. What do you think, or where do you think things like automated testing maybe comes into security testing or securing a UI?
By automated testing, you mean something like
front-end tests.
Front-end tests.
Yeah.
I mean, it has its place. It's again, automated testing. The problem is, at least when I've seen in some tools perspective, that it loses the context pretty soon. You can make very good general cases that can tackle the low-hanging fruits, but there is a place and time for that deep pen test when you have deep application changes like authentication mechanism changes or some other things. That's how to some degree we do our rapid reviews. It's not automated testing, but we go through it. We see that, okay, our questionnaire is designed in a way that it detects the low-hanging fruits, and that is somewhat automated, I would say. And if it triggers that there has been a major application change that requires someone to do that manual testing, they then go and do it. So long story short, automatic testing can help you with the low-hanging fruits and the just the general things, but obviously not everything. Cool.
Else?
Cool.
Cool. Thanks.